Hi everyone. So today we're going to look at the process of finding turning points. Now, turning points are essentially the maximum or the minimum points of a parabola. So as you can see, I have the examples drawn above. So on the left, which looks like a U shape, that will result in getting you a minimum point. Right, and the one on the right, which looks like an N shape, will get you a maximum point. So those are basically what are known as turning points. So we're going to look at three different ways of finding turning points, and namely the three ways are completing the square, all right, using this formula x equals to minus b over 2a to get you the x vertex, and the last one, 3, is using the roots method, where we will try to find the middle position between two roots. All right, so we're going to look at the first example on completing the square. So I will have a more detailed completing a square tutorial later on. All right, let's look at the step 1, completing a square. This is a U-shaped parabola because if you look at the coefficient for x squared, it is positive 1. So we do know that it is going to be a minimum point or the minimum vertex. So what I want to do first is I want to first remove 1x from the x squared and remove 1x from the negative 3, and I'm going to halve the negative 3. All right, I'm going to halve it. So that will result in me getting the value of negative 1.5. Now, once I have that, I will put a square on the outside of that bracket. All right. So once you're done with that, notice that if you were to expand x minus 1.5 square using the identity of ax squared plus bx plus c, you will actually get an additional 1.5 square, which I actually don't want it. It doesn't exist in the original equation. So if you look at the expansion like what I'm going to do here, you see I got x squared minus 3x plus 1.5 squared. So essentially I'm trying to remove that extra term that doesn't exist above. Yeah, so I only have x squared minus 3x, there's no 1.5 squared. So I have to remove it to make sure that the equation is balanced. All right, and then of course I'll bring down the negative 4, which is from the previous working. So I'm going to clean that up. I'm going to add negative 1.5 square with negative 4. That should get me 6.25. All right, so in this state, this is what we call the vertex form. And here we actually can identify our turning point by first using the x value that makes bracket x minus 1.5 squared 0. So what x value makes that 0? In this case, we're going to choose 1.5. All right, and whatever is the y vertex will be whatever's at the back of the equation. In this case, negative 6.25. So there is it. We have the turning point of a parabola. So in this example, our turning point is 1.5 and minus 6.25. All right, so this will be the first strategy, completing the square. This is the bread and butter of how you will actually find a turning point, and you must be skillful at that. All right, so the next technique is using the formula minus b over 2a. So we're going to look at the coefficient for the b, which is basically the coefficient for x. In this case, is negative 3. And we're going to divide it by 2 times of the coefficient for x squared, which is 1. So when I put that formula in and I clean it up, my turning point is, for x coordinate, will be 1.5. Now to find the y coordinate of turning point, I have to substitute 1.5 into the original equation, which is x squared minus 3x minus 4. And that will result me in getting negative 6.25. And notice that these two coordinates is exactly the same as the turning point in the previous working, which is we also got 1.5 and negative 6.25. Now, there is no surprise here because both are legitimate methods of getting you the turning points, right? So we do expect the answers to be the same. All right, so the last method, roots method, is that we are going to find the roots first of the quadratic equation, and roots are basically the x-intercept. So to find the roots, we will equate x squared minus 3x minus 4 equals to 0. We're going to factorize it, and in this case, we are using t-chart to factorize, or in some cases, you can use split the middle term. And I have the two roots that I generate, which is x equals to 4 and x equals to minus 1. Now, notice that the roots are actually evenly spaced out, all right, on the left and on the right. And right smack in the middle, there you will find your vertex x value. So if I can find the middle of my two roots from negative 1 and 4, I will be able to get the vertex x value as well. All right, so how do you find the midpoint? You will basically want to add 4 and minus 1 together and divide that, all right, by 2. So when you have 4 plus or minus 1 divided by 2, you actually get 3 divided by 2, and that will result in 1.5. Now, no surprise here again. With the 1.5, which is your x vertex, is exactly what is confirmed using the two previous methods as well. So, similar to method 2, once we have that x vertex, we're going to substitute that back into the original equation, and that will result us in getting the y value as negative 6.25. So, from here, I think we are good to go to state the vertex as well, and in this case, the vertex will again be 1.5, comma, minus 6.25. All right, so I hope these three strategies has been useful for you to understand the process of finding turning points, and these three methods are all legitimate. You can use it anytime. Preferably, you will have a method that you are comfortable with and you can use it. All right, and I see you in the next video. Cheers.